Hello, friends. Welcome back. Today, we'll be discussing about a very important topic in the field of material science, that is iron carbide phase diagram. So, in the previous class, you might have seen about the phase diagram, especially the binary phase diagram, and we have discussed about basically the four most important phase diagrams, which are isomorphous system, eutectic, eutectoid, peritectic, and so on and so forth. And put together, we'll be having some of them in the iron carbide phase diagram. But before we go into it, let us quickly understand what are the important terminologies. So, myself, Dr. Evarun, and I will be teaching you about the material science and metallurgy course. So, if you're not following my videos, please do subscribe and please do see from the starting video in order to have clear understanding about the material science and metallurgy. Moving on. So let us quickly revise some of the important terminologies. What is a phase? So it can be defined as a homogeneous portion of a system that has uniform physical and chemical characteristics. That is, it is physically distinct from other phases, chemically homogeneous and mechanically separable portion of a system. And when it comes to phase diagram, these are the diagrammatic representations of limits of stability of various phases in a chemical systems at equilibrium with respect to variables such as composition and temperature. And we are going to discuss about a very important term here in iron carbide phase diagram, that is allotropy. So when it comes to iron, pure iron itself has got a possibility of existence of two or more different types of crystal structures at different temperatures. So please look at the video which I have made describing about the different types of crystal structures. Now, iron particularly has this capability of existing more than two forms or more than one form of crystal structure as temperature is varied. So let us see that quickly. Was at delta, right? And the and then we have seen at 9, 10, there was another allotropic change. So all these are going to be observed in a different way. So let us plot them first. So when the carbon is alloyed, it goes up to 6.67 percentage. So we are going to discuss why exactly 6.67, what happens at 6.67 in detail in the next video. But let us understand this 6.67 percentage of carbon is called Fe₃C, which is nothing but iron carbide. So this iron carbide is nothing but it is a compound. So earlier we also discussed this. Compound is such a thing which is going to have a different properties than that of a parent element. So here at 6.67, this particular line represents a carbide, which is nothing but a compound. So we are having a plot between 0 to 6.67 on the x-axis. And this extreme, it is pure iron, and this extreme, you have iron carbide. That is the reason why this plot is called iron carbide phase diagram. Next, we are going to plot them. But let me tell you, we have an easy way to remember it. We can first let us plot it and then try to remember. So we have three horizontal lines. So first one here, and then you can see here is the second one and third one. So if you see, this can be divided into three cross sections. So if you see, this is one cross section wherein you have one horizontal line, and this becomes the second one, and here you have third. Okay, so first let us complete the phase diagram. So if you remember, the first transition, the freezing temperature was somewhere around 1539. So it's the same 1539. Next one is at 1400, and you have one horizontal line that is also indicated as 1492. And then there is 1147, another horizontal line. And we have 910. There was a transition which is from gamma to alpha, and there is another horizontal line at 723. So now we have all the temperatures that are needed. So if you can remember, we had one 1539 getting from pure iron. Then there was 1400, which is marked, and then there was 910. So what happens above 1539? You have liquid. 1539 to 1400, delta iron. 1400 to 910, gamma iron. Below 910, alpha iron. If you still have a confusion, please go back, pause the video, go back to the previous seconds, and then come back so that you'll have clarity. So this is liquid. And like I said, this zone you have delta, and this zone you have below 1400 is gamma, and that is 910. Below gamma, you have alpha iron, right? So this part is it's clear, I suppose. Then comes, we need to, mark. So this side gamma, this side liquid. So this becomes liquid plus gamma. Sorry, this side delta, this side liquid. This becomes liquid plus delta. And then delta here, gamma here, delta plus gamma. Liquid here, gamma here, liquid plus gamma. Then you have liquid here, Fe₃C, liquid plus Fe₃C. You can see here also, gamma here, alpha here, gamma plus alpha. So now the different zones are marked easily, right? And we need to indicate the carbon composition. So here we have delta zone maximum zero point 0.1, and then you have here where the peritectic reaction, we'll see that in a while, but you can see this point here is peritectic, where it is 0.18, and then the maximum liquid plus delta is 0.5, and this point here is 4.3, and this point here is 2%, and this one at 0.8. And you can also see here alpha maximum is 0.025, and at room temperature it is 0.008. So what we are trying to do here is, if you see, we are trying to have a correlation between all the uh, temperatures and different carbon compositions, right? So let us quickly talk about the reactions. But before we go into the reactions, let us divide this so that you can remember and recall easily. So if you see this part, like for example, if I divide this into three zones, let's divide. One second, let me erase. Yeah. So if I divide this into three zone, that is, yeah. So if I take this zone and if I zoom it, you can see clearly that there is a reaction which is, if you recall, it is a peritectic reaction kind of thing, and this one is eutectoid reaction, and this one is eutectic reaction. So the same thing you can observe very clearly, that here there is an horizontal line, right? And this horizontal line is having one reaction wherein liquid plus delta is reacting and giving rise to what is called as gamma. So at 0.18 percentage of carbon and 1492 degrees centigrade, we have liquid plus delta iron giving rise to gamma iron. This gamma is given a name called austenite. Okay. And there is another horizontal line here, right? And here we have seen eutectic reaction. So you have liquid here, and you have this ends of the line. So this end it is gamma, this end it is Fe₃C, right? So in order to give clarity, let me erase this. All right. All right. So here at 4.3 percentage of carbon and 1147 degrees centigrade, we have another reaction which is liquid transform into ends of the line. So this end it is gamma, and this end it is Fe₃C. So liquid gives rise to austenite plus cementite, and this mixture is called lead burate, austenite plus cementite mixture. And the third reaction, if you see, the third reaction is occurring here, which is in the solid state, wherein gamma will give rise to ends of the line. That is, this side it is alpha, which is named as ferrite, and that end is Fe₃C, which is cementite. So at 0.8% of carbon and 723 degrees centigrade, gamma gives rise to alpha iron plus Fe₃C. Alpha is called ferrite, Fe3 is called cementite. So austenite giving rise to ferrite plus cementite. This ferrite plus cementite mixture is called perlite. Okay. So we had one reaction here, which is peritectic reaction, and the second reaction here, which is eutectic reaction. Third reaction here, which is eutectoid reaction. So basically, you have three reactions in a iron carbide phase diagram. So this is a very, very important diagram, and it marks as a important case study to understand how, as carbon is increasing, what are the different microstructures that we get, and how do we uh, change its temperatures or carbon percentage in order to get the different properties. Another important thing is we need to understand that 0 to 2% of carbon is called steel, and 2 to 6.67 is called cast iron. So here we need to mark a note that 0, or to be precise 0.008 to 2% of carbon is called steel, and 2 to 6.67 is called cast iron. So we have in steel eutectoid reaction taking place, and we have in cast iron eutectic reaction taking place. So anything less than eutectoid is called hypo, or anything more than eutectoid is called hyper. Same as the case with eutectic. So we have 0 to 8.8 is called hypo-eutectoid steel, and zero point 0.8 to 2 is called hyper-eutectoid steel. Similarly, 2 to 4.3 is called hypo-eutectic cast iron, and 4.3 to 6.67 is called hyper-eutectic cast iron. Okay. So this is a very, very important thing which you need to understand. This is how we will try to correlate the relationship between carbon percentage and steel and cast iron in terms of the carbon percentage, where is the eutectoid and where is eutectic, and hypo and hyper. So I hope you have understood most of the things. So let's stop here, but we will try to have a closer look on steel, so that how it varies and what are the different forms that we are going to get, we'll be discussing in the next class. So if you have not followed, please pause and repeat the same video again. Do subscribe, do ask me for any more clarification that is needed, and please do not hesitate in passing the comment and taking further inputs, so that this will help me in making the video in a better manner. I hope you got something to learn today. Thank you for watching. See you next time.